Hey everyone, welcome to the IoT Hero Show. With me on the show today, I have my guest, Mrinal. Mrinal, do you want to introduce yourself?
Hey folks, my name's Mrinal. I lead engineering for a company called Fybr, and Fybr builds IoT networks for cities, especially. And I have known Tom for a few years now, mostly over social media. But we recently got to meet in Barcelona, and I think a while before that, I think maybe in Madrid a few years ago as well.
That's right.
Um,
Yeah, so
yeah.
we keep meeting in Spain, which is pretty awesome. There are worse places.
That's true. I actually really like Spain,
Yeah, me too.
especially food is just fantastic. Barcelona was amazing,
It is. It is.
food-wise.
Tell me, Mrinal, when you talk about IoT networks, what do you mean? Because a network is a fairly ambiguous term. It's gotten to be, at
That's
least.
true.
It can mean many
So,
things to many people.
so is IoT, I think,
I
right?
think so.
Well, okay, so I'm going to attempt a slightly longer answer.
Okay.
Um, um, so, um, and I'll start with cities because that's the problem space that's very interesting to me personally. But a lot of what we do applies to other stuff, but cities is interesting. So cities are, they're essentially struggling with the resources they have, right? You can think about all of the things that cities deal with. Traffic's gotten bad to worse in the last 20 or so years. Air quality's gotten really bad. Pollution's gotten really bad. Water has become more polluted and more scarce.
Hmm.
Energy is well, a problem,
Yeah.
right? And the way we use it is inefficient. Um, and all of these resources of a city are just getting scarcer and scarcer. And um, I think IoT sets us in the right direction to use those resources a little bit better than we already do.
Okay.
So, what do I mean by that? Uh, Once you connect the infrastructure of a city, and you start collecting information, let's say from traffic, from parking, from the water mains, the sewer mains, the street lights, etc., you then can control this infrastructure a little bit better because you can start thinking about algorithmic control, right? So you can make decisions about infrastructure several orders of magnitude faster than a human could do, right? And you can make these decisions across the infrastructure rather than thinking about one street light at a time. You're thinking about the entire network of the street lights and their utilization of power, for example, right? And also because of IoT, you can affect this infrastructure by these algorithms, right? So you can collect data from the infrastructure, you can make some decisions, and then the result of that decision could be an effect back to this infrastructure, right? And this space is fascinating to me, and I think that because so many of us live in cities,
Hmm.
doing it at the city level opens up the possibility of us of having a major or a significant impact, at least, right? So that's what fascinates me about the domain, and uh, this just to sort of dig into that algorithmic control bit, right? And give an example, maybe um, parking, right? Has a is a limited one of these limited resources, or streets or roads are one of these limited resources, right?
Yeah.
Now, if we can start by sensing how these resources are being utilized and what their current supply is, all right, how much space do I have available on my road? How much parking space do I have available? And once I understand this supply, and because of apps and things like that, I may understand the demand for this supply, right? Once you have these two pieces, you can introduce incentives and disincentives in the middle of the picture, right? And start to balance out and optimize the utilization of that resource, right? So you could think about dynamically pricing parking, for example, or tolling the use of a road, for example, and in a dynamic way, so that you discourage or encourage certain use scenarios, right?
Okay.
So you can discourage people from driving into the city by saying, hey, today the toll's this much and the price of parking is this much. You can encourage logistics flows to utilize, your trucks to utilize the streets at nighttime because their toll at nighttime is a lot lower or nothing versus them going during the daytime, right? So these levers become possible because you now have algorithmic control over this infrastructure, because these levers are too hard to deal with for humans, right? And it's just too much information, right? You can't think of everything around you as a stock exchange. It's just too much, right?
Yeah.
So you need algorithms to do it. And IoT, I think, is the first step to enable algorithms to do it, right? And today, on the user end, I talked about apps, but it doesn't have to be apps. It can be other things, right? It can be your car. So your car can bid to be on the road, right? And utilize that in the near future, rather than you deciding all the time, hey, today the toll is X dollars and tomorrow it's Y dollars, right? That also is too much. So IoT, I think, is that first step that allows us to deal with infrastructure in a form that can be optimized for best case, right? We're still limited. I don't know how to deal with that problem, right? It's still limited, but how do you maximize the utilization of that limited resource? So I gave the parking traffic example. Similarly, you can take, streetlights, for example, right? So streetlights, right now in most cities are kind of dumb, right? They come on and go off based on these hard-coded timers, or in a better scenario, maybe based on some kind of motion sensor that barely works, right, or gets affected by dust and those kinds of things. So instead, if you can connect this infrastructure, you can start to reason about traffic affecting streetlights, right, or people movement affecting streetlights, or weather affecting streetlights, right? So instead of a dumb timer that says nighttime stay on and daytime stay off, well, what if there's a storm and at that time the lighting in an area is limited and you do want the streetlights to come on, right? I was in Qatar recently for a conference in Doha, and we went outside the city to do these. They call it dune bashing, which is these crazy rides on the sand dunes. But it was kind of fun. But when we were coming back, we were on a road that was largely empty, and it was a completely flat land, right? So you could see miles ahead of you, and it was late evening, so all the streetlights were on. But there were like 4 cars on that highway, right? And the streetlights were on for miles and miles. They don't have to be, and especially with LED, you can, even if you don't want to turn them off, you can dim them, right? So if you have a mix of traffic sensors and streetlights and algorithms in the middle, you can make these decisions a lot faster than humans would be able to reason about or think about or do. So that's the attractive bit. And the other piece that I think IoT networks enable, so one is this optimize the use of these limited resources, right? Air, water, electricity, etc. The other value they bring to the table is predicting failures, right? So using that to improve the service that cities offer to their citizens, right? So you can detect or even predict that a water main is about to overflow and cause flooding. You can detect and even predict that a street light is going to fail. And so these things allow cities to trigger maintenance workflows long before these issues become a problem, right? Mm-hmm. So that's the second piece of value I think IoT brings to cities.
It's funny. It's funny. I was talking to a guy who does the streetlight management for a city in Canada, and he was saying that they've had to implement a smart solution for the streetlights because they were literally weeks behind in fixing streetlights. And part of the reason was that someone would ring up, which was the only way they had of detecting, someone would ring up and say, the streetlight on our street is gone. And that would kick off, that would come into the call center would log it would kick off a work order, which would send a team out who would go out to the street, and there'd be 5 or 10 lights on the street. Yeah. And they'd try and because they were there at daytime, they wouldn't know which one was gone. Yeah. And then they'd make a best guess, and they'd change it. And in the meantime, because there's a delay of 5 or 6 weeks between the time they get the call and the time the work crew go out there, 4 or 5 more calls come in, which kicks off 4 or 5 more work orders, separate ones, which causes this huge backlog, and these crews are all assigned to go out, and it's become self-perpetuating. Right. And so they put a smart solution in place, which allowed people to take a photograph with a smartphone of the light, which of course geostamps it, and also gives the work crew a much better idea of which one they have to change. And then then the work crew go there, change it, and enter it into the system. And this kicks back a message to the person who sent in the complaint saying the thing is gone, saying that workman Y has been on scene and changed the bulb. And so you close the loop. And it meant that the time to fix, the mean time to repair came way down, and the citizens in the city became much happier because A, they reported it, and B, they got a reported resolution back to them, so they were seen to be making the place better. And then they've started to switch over to, as you say now, LEDs, which are then self-reporting and have a much longer lifespan as well. They last 10 to 20 years as opposed to incandescents, which last a lot shorter.
Yeah, that's true, right? So you're absolutely right. I think devices, intelligent devices, will play a role. They're low-cost, picture-based solutions, a good step in the right direction, I think, right? And streetlights are a huge deal, somewhere I read 40% of the spend of most cities is energy cost for streetlights.
Wow.
And
switching over to LED helps them because they as I say, a lot of them are self-reporting, so you now know which ones have failed, and B, they last much longer. They have a much longer lifespan. So you're not having to replace them nearly as often. And C, as you say, the energy consumption that they have is significantly reduced as well. So just on energy consumption alone, you can be saving up to 80%.
Exactly. So it's a big win. And once you think about connected streetlights and then other sensors like say traffic, then you can start to optimize the on time or the dim. And LEDs give you this dimming control as well, right?
That's right.
So that becomes a much powerful way forward as well. So your original question was, well, what do we do? So let me close that loop, right? So that's that problem area of optimizing the use of resources is what interests me, and I think IoT is an enabler to help to get us towards a direction where we can start to utilize these resources significantly better and optimally than we do today. Now, at Fybr, we build devices that can control such an infrastructure, right? So we have a streetlight controller, for example. We have a parking sensor. We have a sewage sensor that can detect level of sewage in a pipe and rate of flow of sewage in a pipe. We have multiple different air quality sensors, weather sensors, traffic sensors, soil moisture sensors. And so we build these hardware sensors most of the time in partnership with domain experts that understand that domain better than we do. And then we are laser focused on solving some challenges that you see again and again as you go across these different sensor types, right? So I think of it as a trade-off between reliability and efficiency. So across applications, you'll notice that you want reliability, but you also want efficiency. And you can think of reliability in terms of, is the information I'm getting accurate? Am I getting it in the right time? Am I getting it securely? And do I get it always, right? So I don't get it sometimes and I don't get it other times. That's also not good, right? Yep. So that's the reliable angle. The efficiency part is, well, can I operate it within the battery budget or power budget I have for that kind of resource, right, in that environment? Can I operate it within the right cost parameters? Can I do maintenance within a reasonable time and within the right cost parameters, right? So there's this trade-off between reliability and efficiency, and it's a thin, fine line across most applications. And we have focused ourselves to making these device networks reliable and efficient, right? That's the problem we're trying to solve. And we realize that the solution to this problem isn't in just building the device or just building the network, the radio network, or just building a server-side solution. So if you look around the IoT marketplace, you see that there are players in all of these segments, right? There are people who build these edge devices, like a smart street light, for example, right? And then there are people who do the connectivity, and there are companies that then do the server-side management of these assets. And our approach is a little bit different because we realize that you can't walk that fine line of reliability and efficiency properly and for the best interest of the customer unless you do all the three layers yourself. So we are focused on that, and we're partnering with experts that understand lighting, experts that understand sewage management, experts that understand water management, etc., to try to deliver these vertical solutions.
Okay, interesting. Cities are a notoriously hard market to break into for anything, but more particularly, I suspect, for IoT. How is that affecting you guys, or how do you manage that?
It is affecting us a lot, right? We're privately funded, and the investors have been patient, which is very important. And secondly, we are to the cities, we want to present models where they see a path that is sustainable, right? That's very important. So, to take an extreme example, it'll be nice to have a radiation sensor network across a city, right? For example, right?
Okay.
But especially with all these mobile towers and all of that operating in our world these days, well, it'd be nice to know how much am I personally affected by that. But there isn't a clear path to revenue for something like that, right?
Sure.
So what that does is that you may get somebody to invest in the initial cost,
Mm-hmm.
but in 2 years that thing will break, or in a year it'll break, and then there's no sustainable model to sort of keep it going, right? So instead, what we're telling cities is that you should start with applications that either make money or save money to the city, right? And that way, parking is a good example of that. With a parking sensor network, given that parking is across most cities is a paid thing now, right? So you can show a improvement in efficiency of utilization, right? And hence a return on investment in a year to 2 years for most parking sensor deployments. This happens because if you know where to go park, you don't spend time circling around looking for parking.
Yep.
If you're spending 20 minutes, let's say on average everybody's spending 20 minutes looking for parking in a downtown of a city. That means, as a corollary, it means 20% of traffic in downtown of a city is caused by people looking for parking, right?
Yeah.
So that's 20% more traffic, 20% more pollution, 20% more noise, 20% more frustration with finding parking, right? So by telling people where to park, and it starts with knowing where to park, but then can go on to giving you recommendations based on machine learning on where to park, you can minimize or reduce that traffic, right? And optimize the use of parking itself. So what we've noticed in many of our deployments is that even though you'll find people looking for parking, it isn't so that the parking isn't available, right? Parking's available. It's just that you spend time going in circles looking for it, and by the time you get to it, right? And we often see about 80% utilization in downtowns. So that the remaining 20%, if we can improve the utilization, we can increase the revenue of the cities. And so that allows us to show that, in somewhere between a year to 2 years, your initial cost of investment into that parking sensor network, it'll come back, right? So that's good. And then what you make after that is profit, right? Yeah. And this future profit and the existing network can both then be used to enable applications that don't necessarily make money, right? So you can have a radiation sensor network, because once you have a parking sensor network in place, right? And because you then, in our case, you can just overlay a new sensor type, and the cost of that is probably a few $100s, right? That's it, right? And you now have that. I'll give you an example of this. Washington, D.C., we have a deployment in downtown of Washington, D.C., and the discussion with Xerox, who's our partner there, and they do the parking management and city mobility management in D.C., the discussion with them is that can we now have a network of air quality sensors layered on top of the parking sensor network, right? Yeah. And so a network of air quality sensors.
You're using the same comms network, basically.
They're using the same comms network, the same poles, the same gateway boxes, also, right?
Yeah. Yeah.
And so we already have those gateways. We just have to go plug a device into their USB port, right? That's it.
Yeah.
And so the cost is orders of magnitude lower compared to just building a network for
starting
air
from
quality,
scratch. Yeah,
right?
Yeah.
And you can provide this service that is valuable then to several applications, right? To start with, the use case they want to do is they want to do route recommendations for bike riders,
right?
To say, hey,
based on air quality,
there's an air quality problem today. Don't ride via this route, right? Especially if you're asthmatic, that's a significant detail. And bike riders expose themselves significantly more if they're doing strenuous exercise, right?
Yeah. I can imagine this being very useful for the couriers who are on bikes.
Exactly, right? And you can think of layered applications, right? If the couriers are using that, the liability on the courier companies from an insurance perspective is higher. So you can start to balance that out and give better incentives to improve the health of the courier and also manage your business costs and those kinds of things. An interesting example of a similar thing that that recently kind of excited me a lot was with a company that does autonomous vehicles, and they're running autonomous buses in Switzerland and France right now, and a very small number, about 10, 15 of them. And these buses are right now being used as tourist buses because they're new, they're autonomous, so people are kind of intrigued by it, right? But if a tourist boards your bus and it's an open bus, you don't want to take them into streets that are heavily
polluted,
bad breathing, right? And you kind of kill that experience. So they want to optimize that. But there are several applications of a micro detail level air quality or weather network that otherwise doesn't have a clear path to who will build it, who will make money from it, how do I return from it? It's not very clear from a city perspective. But once you do something like parking or streetlights, which again save a lot of money in terms of energy efficiency, or sewer has some interesting examples on how you can save money there. So to answer your original question, how are we approaching it? We're approaching it by telling cities that, look, the first application you should do is something that either makes you money or saves you money in the near term. And then layer applications that don't necessarily have a clear sight to revenue, but are value adds for your citizens and even in your own efficiency, right?
It strikes me as well that if you're rolling out at the same time, as opposed to waiting a while, if you're rolling out at the same time, the parking sensors plus the air quality meters, then you're able to do a baseline on air quality and see if the rollout of the parking meters helps improve air quality.
That's true, right? Yes, that is very interesting. We haven't had a case of that yet, but it is interesting. And we've used other mechanisms to study the impact. We ran a study in I think it's a small town called Eaton, Pennsylvania, a few years ago, and we were able to show that and it's a small downtown, about 500 parking spaces, and we were able to show that the retail revenue connected increased on certain days by having a parking sensor deployment, right? And so how does that work? That works because you have limited time on a Friday evening to go shop, right? So if we can reduce 20 minutes of looking for parking time out of it, then we can cause you to spend a little more time in the downtown, buying ice cream, buying whatever, right? So that was a interesting way to measure the impact that we've tried, but there's a lot more to be done in terms of studying impact, I believe.
Fascinating. IoT in general, I mean, you've got an interesting slice of it, and one that I think readily benefits people's day-to-day lives in your deployments. But IoT in general, the way I kind of say it to people is I say, think back to where the internet was in '94. Where the web was in '94. Some companies had a website, some companies had a corporate email address, but they certainly didn't have email addresses for everyone in the company. And all that's changed in the 20 odd years between then and now. And then try and put that in place. Try and incorporate the changes that have happened in the last 20 odd years on the web, and try and project that onto where the IoT is, because I think the IoT is today where the web was in '94, '95, that kind of time frame. And I think there's a huge runway for IoT. What do you think on that? Do you think I'm smoking crack, or do you think I'm on the right track, or is that a good analogy?
I think it's a good analogy. I, of course, have skin in the game, right?
Me too.
I may be biased from that perspective, but I think it's a good way to think about it. I think that there are layers of value that'll get realized once you have the basic infrastructure in place, right? So we're very much at the early stage where we don't even have, on your previous episode, I listened to the standardization discussion, right?
Yeah.
And we don't have that kind of infrastructure. Internet standards were established now 20 years ago, right? And that enabled a lot of value. So we'll get these layers of value as we get, once we put the basic infrastructure in place. And right now, the IoT world, right, or market, is very much at that early stage where different people are trying different things. There isn't any real consensus on what the right approach is. But once we get there, I think people will start to understand and imagine applications that I frankly haven't yet comprehended.
Yeah, I mean, back in '94, who could have predicted Twitter or Facebook or
Exactly.
Yeah, it's been fascinating to watch the changes in those 20 years. But 20 years is obviously a bit difficult to predict, but 5 years out, how do you see things changing?
Okay, so 5 years out, I think the things we currently have, right, all the things we currently own, will be connected, right? So anything that you can imagine, it will get connected. It may not be connected in a uniform way so that everything can talk to each other, right? But I think in the next 5 years, we'll manage to get to a point where, your refrigerator, your air conditioner, your power supply, these things will get connected. We're already kind of there yet. Right? City, street lights, roads, traffic lights, cars,
glasses,
spectacles, right? Things will get connected. So I think in the next 5 years, we'll get there where everything's connected. We'll go through a phase where people will start to realize that there are some incredibly difficult things, difficult problems that we aren't paying attention to yet, right? So the issue that bothers me in the IoT world these days is that on one hand, tools like the Raspberry Pi or the Arduino are very encouraging because they give you a glimpse of what's possible and they make it seem like it's really easy to do, right? And that's great, right? You go to a little hackathon, one evening, you come back in a few hours and you've built something that actually talks to the internet, right? And it's kind of cool. But what it does also is that it creates this illusion that pulling this off at scale is very easy, right? And that isn't necessarily true. And I'm saying this from experience, right? So there are some incredibly difficult problems that aren't getting enough attention. Security is one of them. Efficiency is one of them. You can get a $5 Raspberry Pi, right? But a Raspberry Pi is a full Linux computer, right? It consumes resources like a Linux computer. And if you want to put a device inside the sewer, you don't necessarily want it consuming power like your laptop, right? You don't want to be charging it every day. You don't want to. You don't have the luxury of maintaining it every day, right? So if you're putting a device in such environments, then you have to think about accuracy and reliability of the information, the battery life, the power source of how you will power it, sustainably over several years, and still be cost effective and have useful information to work with, right? And this area, I think, will need attention. And this is the area that I'm most familiar with, but I'm certain that there are spaces or gaps in this conversation that haven't been talked about enough yet, because we're all very excited about, look, I connected my refrigerator to the internet, right? So I think in the next 5 years we'll connect everything, but then we'll also start talking about some difficult challenges
and some realistic use cases.
Sorry,
real use cases. I mean, connecting the refrigerator. I mean, I can see some uses, but it's when you see things like the Amazon Echo, maybe then some kind of merging of the two things there. Or the dash buttons similarly. But there are far more useful things to connect to the internet, I think, possibly than your fridge.
Yeah, that's true.
I think we're going to see a massive growth of the industrial internet before we start seeing it in the home. Just because for economies of scale, it makes far more sense for industries and cities to invest than it does for people in their own home. I mean, why would you spend $50 on a Philips LED connected light bulb when you can get a Philips unconnected LED light bulb for $5? You know, what are you getting for that extra 45? You know, a Zigbee and a Zigbee radio, which, you know, the ability to change colors remotely.
You said something in one of your in the Technology for Good show several months ago, maybe a year ago, that has stayed with me. It was this example of a utility company somewhere in Europe that was incentivizing their end users to install the Nest thermostat. I think they were giving it for free, for example, right? And this is where your economy of scale point makes a lot of sense, right? To an individual user, the value delivered from a Nest thermostat it's there, but it's less. But to a grid, the value delivered from a Nest thermostat is enormous, right?
Exactly.
So I think you're right. It is going to be infrastructure and industry driven.
And it's not just this. It's not just you're right. It's not just the Nests though, and the light bulbs. All these things, I think, will be driven, to your point, by industry, by the utility companies, by the insurance companies. You know, the utility company will say to me, Tom, we want you to install all these light bulbs. We'll pay for them, but you need to give us access to their data, for instance. Or insurance companies for flood damage to your home or for smoke alarms in your home. The insurance companies care about catastrophic things happening to your home, like floods or fires.
I'll give you an interesting insurance example, right? I spoke with the CTO of City of Amsterdam several months ago now, and the discussion was incredibly interesting, right? So Amsterdam is a lot of buildings in Amsterdam are standing on these wooden pillars that are submerged in water or marsh, right? And they have put in 3,000 plus wells all over the city,
right?
And where they manually go every few days and take a reading of the groundwater level, right?
Okay.
The reason they're doing this is that if the groundwater level falls, then those wooden pillars get exposed to air and may become weak, and the buildings in the city may fall, right? So they want to carefully track groundwater level. And the discussion we were having was, okay, can we connect those so that you don't have to send somebody out to do that collection, but we can do that automatically. But the more interesting part of the discussion is this, right? The pillars are technically owned by the city. The groundwater is the city's responsibility.
Okay.
But the building and the maintenance of the pillars under the building is the building owner's responsibility.
Wow.
Right? So think about the insurance impact in this, right?
Mm-hmm.
So what if the city's groundwater level starts to fall? Who's liable, right, of all the problems that may arise from that? So that conversation was very interesting, because the discussion we were having was, okay, can we start to measure the amount of rainwater a building releases to the ground and start incentivizing them for that release, right? So if you have a measure of how much water is being collected on your roof and what percentage of that are you releasing to groundwater level, once you have that measure, your insurance could get tied to that in some way, right? And so this is, I don't even claim to comprehend what the complexity of the solution is, but we're headed towards that kind of setup. And it'll be algorithms, right? Humans will not do this. It'll be algorithms deciding on our behalf. And in algorithms deciding on our behalf, you end up with these situations where I don't know what algorithms will do, right? The best example of that is this whole autonomous car situation, where if the odds, from an algorithm's perspective, if the odds of the person in the car in an accident scenario, if the odds of the person in the car dying and the odds of the person outside the car, a pedestrian in front of the car, dying are equal, or maybe they're not even equal, right? Well, what should the car decide to do?
Who does it
right?
kill?
Who does it kill, right? And this problem is very interesting, but at a smaller scale, I think these same kinds of algorithmic dilemmas will arise, right?
Yeah.
And who wins is a difficult answer when you have algorithms doing all of that decision making. Anyway, I kind of went on a tangent, but
Okay. We're running out of time, Mrinal. Can you quickly tell people where they can come across you and Fybr?
Absolutely. We are Fybr is at Fybr spelled Fybr, and we are at fybr-tech.com. And you can find me on Twitter, and my Twitter handle is Mrinal, Mrinal, my first name.
You got in early.
Yeah, I got in early. Oh, they ran a little switch your Twitter handle thing a while ago. That's how I kind of got it. 2007, I think.
Yeah. Cool. All right, that's been a great show. Thanks very much, Mrinal. And if I'll put your Twitter handle and the company URL in the show notes for people to see. And tune in again, folks, and we'll have another great show of IoT Heroes. Thanks for listening.